good morning. It gives me great pleasure to be on this dais, CRC, where I worked for 25 years. And that too, it's a great honor to be presenting a small lecture in front of Padma Shri Padma Bhushan, Dr. Saraswat, whom I have been watching from distance. He's a dynamic leader, eminent scientist, and very active and very dynamically thinking about innovative concepts for nation building. And it gives me really great pleasure to give this small overview of emerging trends in energy engineering structures. I also thank my colleagues on the dais, off the dais, and my fellow ladies and gentlemen. Thank you for the opportunity. Let me start my topic, which is again, I used ChatGPT AI for the first time to create these quick slides. And with that acknowledgement at the bottom of the slideshow, let me go through the slides. So we have, SCRC is not new to power plant structures, be it chimneys, cooling towers. We have been doing wind analysis, design reviews, and consultancies, and so many other things. And turbo generator foundations is a regular consultancy for us. And this one. This is to slide move. Okay. Yeah.
Check.
So now we are in the renewable regime. India has set a target of 500 gigawatts of renewables by 2030, which is a very huge target. In 2014, it was just a mere 20 gigawatts. And 2014, they announced 175 gigawatts. And by 2022. But now, after COP27, Honorable Prime Minister has announced 400 gigawatts and 500 gigawatts now by 2030. That's the target of renewables. And we are getting fast track towards that project. And some of the structures which you might come across in future would be offshore towers, floating and fixed, and very tall wind turbine towers of 120, 150 meters tall, and very large wind turbine blades, right now up to 60 meters in India. In the world, it is about 130 meters. And India's largest floating solar project is in Kayangulam, Kerala, which is one of the largest, 101.6 megawatt project. So what are the challenges in traditional energy engineering? Why we call it energy engineering? You think of any energy, they require structures. It could be a pressure vessel, it could be boilers, it could be support structures, it could be foundations, towers, and blades for the case of wind turbines, and so on. And the traditional energy structures had limited sustainability because it cannot go further because the resources are limited, resource dependent, fossil fuels are going to be depleted soon, and high environmental impact. It has a very high pollution in the ground. So we are now moving towards renewable energy sources. Cautiously, India has declared net zero by 2070 because as a developing country, we cannot use base power other than coal some more time, for some more years. So structural design challenges are going to be there in renewable system when we are moving towards net zero by 2070. Economic viability and rising demand for renewables now, and that cost is increasing. That means we have to cut costs somewhere, that for which it required a lot of innovations. And technological advances for offshore and onshore. And also what you see here is a solar thermal tower. The solar heat is reflected onto a tower wherein you can get superheated steam, and then that can ride a boiler generator and you can generate power. So there are umpteen ways of using renewable sources of power and generate, but every source of power, when you want to convert to electricity or any other means of energy, we need structures and systems. and which require enormous input from structural engineers. Innovative materials and technologies in structural design for future trends, and some of them I can highlight. Advanced composite materials are being used now, and smart building systems are going to be there because green buildings require embedded sensors into the building materials. And you have to manage the energy, net positive energy of the building has to be there. And 3D printing, already SCRC has demonstrated 3D printing innovation in a small scale, and it will be going to be there in prototype soon. Then we have energy efficient strategies. When you want the green buildings, for energy efficiency you need support structures, sensor supports, sensors should function and meet all the functional requirements, and passive design solutions with low energy consumption. Passive design solutions are required, for which structural forms and the design of that is important. Then we have to have IoT, Internet of Things, enabled devices, sensors being embedded, and it will improve operational performance, easier maintenance, and energy engineering systems. And we need of all the things synergy from CSR, SCRC with National List of Wind Energy, National List of Solar Energy, National List of Bioenergy of Ministry of New and Renewable Energy, along with the International Solar Alliance, which is one of the topmost apex bodies in the world, headquartered in India. And we need to ensure in future the P2P, person-to-person energy sharing within connected community, because energy is going to be digitally managed. No more distribution systems are analog. It will be controlled by digital networks. Offshore wind power developments are very fast. Most of the countries which are dominant in offshore wind energy exploitation, they have taken about a decade or so to take their first offshore wind farm. We also started in 2010 with the offshore wind energy discussions with Scotland, and now we are in a position to leave out a tender for Tamil Nadu, 4 gigawatt in Tamil Nadu, leasing 1 square kilometer of seabed for the highest bidder. 1 square kilometer of the seabed leasing for seabed survey, marine biodiversity surveys, and so many other things which are involved in offshore wind power development. All the surveys have to be completed, and seabed exploration and seabed, the suitable foundations have to be designed. And we can think of in one machine 15 megawatts with 236 meter diameter blade. That is such a long blade. In one machine we will get 15 megawatt. That's the order of scale of development nowadays. And this is a large wind turbine blade under test in Denmark, Blast company. And the testing is happening in the ambient outside environment. And the vibrator is to simulate the fatigue stresses on the blade to endure the fatigue life of the blade. And another important thing is, when you design the blade, it has to be designed for logistic transportation along the roads and to be taken through the barge and to be installed in a site in offshore industry. So there are several things structural engineer have to think of while even at design stage. Okay, if you just look at the case study of floating solar farms, it utilizes unused water surfaces, enhances renewable energy capacity, energy positive buildings, ensures surplus energy, offers potential for sustainable urban development, and digital twins and blockchain for supply chain management. This is going to be there in offshore wind turbines, wind farms, because offshore wind farms cannot be accessed as and when required to rectify defects. They have to be very highly reliable, and the access is limited because it is seasonal. You have to wait for the sea to be calm before you access the defect addressing, or you have to go through a helipad and so on. So digital twins is going to solve these overall problems. And future outlook, emphasis on energy decentralization through microgrids, and we'll come to that in future in the next few slides. Integration of AI and machine learning in predictive energy management, smart grids, and so on. Innovations in wind turbine blade structural designs definitely largely depends on the structural engineers, building in efficiency in the blade, aerodynamic design, as well as the structural design. And performance, the high performance, then you get more energy captured. The environmental impact will be less because the noise will be less and the death of birds or bats will be less. And other challenges in traditional designs are fatigue and manufacturing complexities. They're all becoming overcoming now with innovations in material. Conventional materials are used for blade construction may have limitation in strength, weight, and nowadays we are using carbon fiber, material advancements, blade materials, smart polymers, and morphing of blade profiles like the sea animals, large sea animals, and aerodynamic bird wings and so on, and design enhancements, integration of technologies, both digital manipulation of stresses in the blades. You can embed fiber optic sensors inside the blade during casting and monitor it 24/7. And these are all the gains you will get such innovative designs are, if you use advanced composites, the performance increase is about 12%. Morphing blades can increase performance by 18%. Smart polymers can increase by 15%. So we have, structural engineers have a large role to play in the future. Not only in the blade design and efficiency building, even after the end of life use of the blade. The Denmark has showcased how you can use the end of life use of the blades to bus shelters and how to use them in integration, collaboration, and so on. And this is going to be there. We will be coming to these things future. That also requires structural qualification because it involves public being sheltered in bus shelters and so on. Then challenges in traditional support systems. Onshore, we have seen the height will be limited, the length of the blade will be limited to transfer through rural roads, and offshore that limit will be obviated because you can create in the factory coastal area and unload any size of the blade, any size of the tower, any weight of the nozzle onto the barge and go to the site and install and commission. So all these sustainability and environmental impact must be addressed. And also in India there is only one company right now supplying, one or two companies supplying tall reinforced concrete towers for wind turbine supports. But there will be 30% cost saving than steel, and you can build and reuse the concrete towers built in forests because you can take only the materials without cutting trees and then erect an in situ concrete tower or a precast concrete tower, and then the same tower can be used to, when you want to upgrade the machine, you can use the same tower with a upgrade because its life is durable, it's long lasting. So 30% cost saving there. Beyond 70 meters design, it could be 30% saving. Then enhancements in offshore wind turbine supports, and we need to have factories on the coast so that you can load out like 3,400 tons topside, which is a substation, will be supported by 1,400 tons of jacket. And it should be corrosion resistant, and floating platforms also are going to be used. Adaptive foundation systems like friction bucket, suction bucket systems which will adapt to the seabed shape automatically. All those things are going to be there, which are going to be the challenge. Onshore, offshore support, design flexibility, you have limited by land availability, adaptable for deep water in the case of offshore support. Construction costs, lower initial cost in the land, but higher initial cost, but the potential yield is much more higher. 10 to 20% more energy can be captured in the offshore because it is a smooth surface. It's not a turbulent wind during the energy production. Not during cyclones, it is not possible. Beyond 25 meters per second wind, most of the wind turbines will be stopped to resist the extreme wind. And maintenance accessibility is easier in land, but it will be highly challenging in offshore. That means you have to build in a lot more reliability through digital twins and IoT and ICT and so on. Then hybrid support systems, optimize energy capture. You can tune the floating platform to any kind of sea state, and that kind of systems are going to be there in future. And there are many features. I will leave the slides with you to read because of the short time limitation, I'm rushing through the slides. Right, structural integrity. When it comes to solar, which has taken over the wind now, even though it started late, it has taken over the wind in a big way. The solar integrity, structural integrity and weight and load distribution, you need what is known as a duck row, kind of a solar, floating solars are coming up now. Adaptability and modularity must be ensured in solar. So solar has three fields. One is photovoltaics on ground, then float voltaics, floating solar systems, and then third one is agri-voltaics. I'll come to that one by one. Innovative design solutions for float voltaics. So these are some of the innovative things coming up in solar. That is integrated smart trackers. As the sun goes from east to west, it will track smartly, and that will increase 20% more energy production. And this is different bifacial modules and different curved element, floating elements. This second one, what you have, that's also in another. These are all prototype, already implemented, not imagination. Then materials and construction techniques, high strength alloys are being used. Already we started with rolled steel initially when the solar farms. Now it's cold form steel. Now it is high strength alloy steels. And prefabrication, modular assembly, recyclability and circular economy must be ensured at design stage by structural engineers. Okay? And solar is mostly a EPC contract. It's a plug and play system. And structural engineers have a lot of role to play there. Right? Then environmental impact and cost analysis in solar. We have sustainability metrics, life cycle cost analysis. We should be proud that world's largest gigawatt solar park is India. India's pride is already given in the National Geographic. Can you try to play the video for 1 minute? If it is working. It's partly in Hindi.
शुरुआत पार्क के साइज से करते हैं। ये पार्क इतना बड़ा है कि यहाँ मुंबई के वानखेड़े स्टेडियम जैसे 1000 से भी ज्यादा स्टेडियम बनाए जा सकते हैं। अब जरा इन सोलर पैनल्स को देखिए। सूरज की किरणों से पावर जनरेट करने की जिम्मेदारी इन्हीं की है।
India is blessed with sunshine and 330 days to 350 days in a year, bright sunshine, which is about 5 hours per day, bright sunshine. So that helps in solar power generation.
चलिए मैं आपको समझाता हूँ कि ये पार्क कैसे काम करता है। जब सूरज की किरणें मॉड्यूल्स के सेल से टकराती हैं, तो इलेक्ट्रॉन्स काम करना शुरू करते हैं। इससे डायरेक्ट करंट बनता है और सोलर पैनल्स की वायरिंग में कैद हो जाता है। फिर इन्वर्टर्स उसे ऑल्टरनेटिंग करंट में बदल देते हैं और क्लीन रिन्यूएबल एनर्जी बना देते हैं।
In quantifying the wind loads in these kind of large solar panels,
और पैनल्स पर धूल जमने लगी है।
methods. SCRC is working on it because the
dust is a major challenge for any solar power generation every day because of the wind. So the sand gets deposited on the solar panel.
In 100 megawatt solar
पैनल्स की सफाई के लिए इस्तेमाल किए जाते हैं स्टेट ऑफ द आर्ट पावर एफिशिएंट रोबोटिक क्लीनर्स।
by proper design.
ये इकोपिया रोबोट्स व्हील्स पर।
So this is, they use a robotic cleaner, right? Yeah, go to the next slide. No problem. Okay. This is another area which I said agri-voltaics, wherein we have to allow the cattle to clean up the grass, because we have to keep cutting the grasses under the solar panels. So we have to allow the cattle to go through the grass. That means it requires very proper design of the height of the module mounting structure. These things are yet to come up in India. If this happens, we can have even agricultural lands being used partly for these kind of solar farms, for microgrids and so on. Then the last one I would like to touch upon is green hydrogen innovations and renewable energy dependency. Green hydrogen is produced with renewable energy as the input. In that case only we can have green hydrogen. And there are other ways of producing renewable energy. Hydrogen production heavily relies on renewable energy sources, and scaling production and cost-effective electrolysis must be done. And of course, hydrogen applications are plenty. Pharmaceutical, transportation, synthetic fuels, upgrading biofuel, ammonia fertilizers, metal production, chemical industries and so on, ammonia production, fertilizer production, everything. So in addition, it can also be used as fuel in fuel cell cars. Novel engineering solutions use novel electrolysis techniques which will use solid oxide electrolysis cells and proton exchange membrane electrolyzers, smart grid integration. This is one such system formatted by Siemens Gamesa, integrated renewable energy system for hydrogen production. Storage technologies also, we can use natural caverns, salt caverns, and or you can build underground tanks which will resist the pressure of the compressed hydrogen storage, liquefied compressed green hydrogen storage, and that can be used as and when needed in the grid to manage the grid. And transportation innovations, hydrogen can be transported continentally by storing in liquid form, just like petrol, because I just want to remember, hydrogen is not a fuel, it is an energy carrier. When you convert in terms of renewable energy, it is only a carrier. It can be stored and transported everywhere. Okay, when it comes to these kind of systems, structural engineering systems, we need head of service operations, head of learning and development for industry, head of supply chain, then head of environment, health and safety, quality, SCADA system, and health of technology. Or we need energy engineering projects, we need competence of the people. That's what SCRC is already doing periodically through advanced training in very highly multidisciplinary areas of structural engineering. And we need this because ICT, IoT, in Industrial Internet of Things, digital twins, blockchain, AI, machine learning, virtual reality, augmented virtual reality, you can name new technologies that are going to come up with all this. Structural engineering is merged with every discipline, and it has a multidisciplinary approach. We need to develop the people. Finally, I acknowledge the resources, including the ChatGPT, which helped me to form the first profile. And I thank SCRC to give me this golden opportunity to address you all, to interact with you. Thank you.
Thank you so much, sir. It was a fitting first lecture for our Diamond Jubilee lecture series. Thank you very much for that. Every year, our Foundation Day is celebrated with a memorial lecture in the memory of one of our visionaries, Professor G.S. Ramaswamy, the founder director of CSIR SCRC. This year, we are honored to have Dr. Vijay Kumar Saraswat to deliver this lecture. Before we move on to the lecture, I now invite Dr. J. Rajashankar to formally introduce him to the audience.